The first time any PowerPoint or even image comes up, it may take a little longer. Okay, this is where we left off, and you're seeing it too, please.
Yeah, we're not seeing it.
You're not seeing this?
Mm-hmm.
The screen isn't sharing.
Okay. We are recording, and now we're sharing. Here it comes. Okay, hang in there. Coming back. Are you seeing the screen now?
Yeah.
Okay. And that was the final slide? Okay, thank you, Amira. Okay, so now we're back on track. Okay. And it is recording. Says it is. Okay, good. Okay, repeating. Chyme is the digested, partially at least, digested food, leaving the stomach. The stomach's not shown here, just a little piece of the pylorus. And it goes through the pyloric sphincter. The diameter of the pyloric sphincter is such that it is the smallest opening that anything has to pass through in the GI tract. If it's going to get through the pyloric sphincter, it should be able to get through everything else. And then you enter into the duodenum, the first part of the small intestine. The small intestine is the prime site of digestion and absorption. Digests more food here and absorbs it here. Not just in the duodenum, which I'm showing, which is the cutaway portion. This is the duodenum. It circles back under the stomach and surrounds this organ, the pancreas. The duodenum also has circular folds on its inner lining. This greatly increases surface area and also helps to push the contents forward when there's contraction of the intestine itself. Some new books like to call it circular folds, but we're not going to go that way. We're going to use the old term. It's in greater use, and I think it probably will outlive the term circular fold. The term is plicae circularis for these, yes, folds, plicae circularis. And of course, if you translate it, it means circular folds. The duodenum then extends from the pyloric sphincter around and ends here at this flexure. And then the jejunum, the second part, and the ileum, the third part or distal part of the small intestine come into play. What gets digested in the small intestine? Well, some things have already been partially, at least, digested in the stomach, but coming into the small intestine for further action are carbohydrates. Carbohydrates are not digested in the stomach. They wait until they get to the small intestine. Yes, a small amount of carbohydrate is digestible in the mouth, but we swallow the food too quickly to have it really do much good. Okay. Protein is further digested in the small intestine, and fat is emulsified in the small intestine. Some fat could be emulsified in the stomach, made into smaller and smaller droplets just by the churning of the stomach. But the real emulsification is done in the duodenum. Notice right here a little dot. That's an entranceway. We'll be talking about it in a second. Before we can talk about just any one thing like the duodenum, we need to include some of the accessory organs because they work together. The largest of the accessory organs of the digestive system is the liver. It's got over 500 known beneficial functions. Don't ask me to list them. I wouldn't ask you to list them either. But the most relevant ones are pointed out here to you. The first one is the production of bile salts. You can call it bile or bile salts, but these things, these chemicals produced by the liver make their way to the duodenum and small intestine, where they act to emulsify fat. If you don't eat fat, okay, or whether it's routine or just not in a particular day, this bile salt could be wasted if it's not stored. And rather than waste it, it will be stored in the gallbladder, which is coming up next. Okay. The bile or bile salt is important for the emulsification of fat so that it can be absorbed across the intestinal lining. A second function of the liver is detoxification of the blood, removal of poison. Alcohol is the one most people are familiar with. It takes an hour or a drink or something like that to denature the alcohol. There are other poisons that can get into your body. Did you ever eat sour grass? I love that stuff. I'd go find sour grass and then I'd charge the rest of my kids a nickel to tell them where it was. And then they can go and eat it. But I made a profit off that stuff. Sour grass is oxalis, a plant, nice little flower, beautiful green foliage, and poisonous. It stays in your body for your entire life. I didn't know I was poisoning the kids, but they were paying me for the privilege. Okay. Some of the calcium oxalate can be removed or detoxified by the liver. The liver's not perfect. It won't detoxify everything. For instance, some of the death cap mushrooms, you eat one of those and you're dead. That's it. The liver has never evolved to the state where it can detoxify the poison in one of those mushrooms. And so those people are eliminated from the gene pool who might otherwise breed some resistance. There's no opportunity to breed resistance. we take toxins in all of the time. Listen to any of the nutrition stations or commercials, and a toxin is defined as anything they're not selling. And at least in their minds, I think. Okay, so we have the production of biosalts, detoxification, or removal of poisons. The liver also serves to get rid of aging red blood cells. We lose 3 million red blood cells a second. The bone marrow has to replace those 3 million a second with 3 million more. Okay, the 3 million that are aged and dead have to now be removed, and they'll be removed by the liver primarily. And while the red blood cells are being removed, the iron that they have in their hemoglobin is being retained in large part by the liver for other functions. The liver also stores excess sugar in the blood, and it stores it as glycogen. This is going to be more important next week than it is today. Glycogen is a storage form of sugar. A potato is a storage form of starch in plants. Well, when we have a high sugar content in our blood, but our body tissue doesn't need it, like when, for instance, we go to sleep, the blood doesn't retain that high sugar content normally. Instead, it converts it in the liver to an inert compound called glycogen, where it will stay until there is some activity, usually in the morning. When you drink a cup of coffee, if you do, in the morning, you're not only getting a caffeine rush, the caffeine stimulates the reconversion of glycogen back to sugar. So you're getting a sugar rush as well from a black cup of coffee. If you've also got sugar in the coffee, you're getting quite a dose, probably the equivalent of a jolt or something like that. And then the maintenance of the status quo.
I have a question.
Yes.
What if, like, how do you explain people who like have drinking so much coffee that like it doesn't affect them anymore? Like they don't get like a jolt.
I think that's called a tolerance.
Yeah.
Or in my life.
Habituation, tolerance.
Okay.
It can happen, but you know, I don't think it happens in everyone. I used to go to an early morning class of mine that started at 8. Oh, God forbid, 8 o'clock classes. But I would come down to the old A building on the lower campus. You've probably never seen it. It is still there. The old temporary building, temporary for 40 years here. And I'd walk in, getting ready to check my mail and stuff before my class. And here would be 4 guys, older men, older than I am anyway, and they'd sit 2 on the side of a coffee table, 2 on each side, 4 of them. And they just stare at each other. White-haired guys with red noses. It's almost Christmassy. And then they had yes, secretary was the term in those days. I'm not going to skirt history for the sake of any political correctness. The secretary would bring them coffee. That's nobody's job, but they did it anyway. And they'd sit there and drink coffee and drink coffee and drink coffee until they sobered up a little bit. They were all drunk as skunks, and they were all business science instructors. Anyhow, they would have also with that coffee the conversion of the glycogen into sugar. You know, when Lee, you were asking about tolerance, I wonder if it's a tolerance uh, to the sugar itself, rather than a tolerance of the caffeine breaking down the glycogen to the sugar. It leaves an open question that we can't answer here. The gallbladder stores excess bile produced by the liver. Why would the liver produce excess bile? The liver is producing bile or bile salts all of the time. It's one of its main purposes for the emulsification of fat. But if you're not pushing fat through your small intestine, then it'd be a waste to dump the bile in. Instead, it's stored until the capacity of the gallbladder is reached. Let me take a look up here. No, got to go down farther. Okay, you'll see a picture of the gallbladder in the next page here. Excess bile is stored in the gallbladder. When the gallbladder fills up, any more bile that the liver forms, and you're still not eating fatty foods, it is going to do what? The pressure inside the gallbladder, the pressure inside the liver of making more fluid, the bile that is not needed, would be overwhelming. So it leaks out slowly, drop by drop, continuously, as a safety valve into the duodenum. Okay, but we don't lose it all. We want to keep a full load of bile in the gallbladder for that time when somebody eats something with mayonnaise on it. Do any of you not like mayonnaise?
Yeah, it can't be too much.
I think it's the worst food in the world. Oh, I hate mayonnaise. I think if I'd have seen everybody, I only see a couple of people showing their faces with the video on. It's not required. I can't see what the others are thinking because I'm not hearing what they're saying. But usually in a class, I find about half the people would never touch mayonnaise. It would make me gag. I couldn't stand mayonnaise. The reason is not that maybe I don't like the taste. I don't anymore. But when I was a kid, my sister, 1 year younger than me, I told you about her before. My sister and I were taken to a babysitter. Now, we didn't use babysitters back in 1950. We didn't use them much anyway because we didn't have the money. But my mother was being naturalized. She was over here from England as a World War II bride, and she was getting her citizenship. So she had to go study in a certain place, and so we had to be dropped off. My father was driving streetcars in Los Angeles, so he couldn't take care of us either. So they had a babysitter. The babysitter was an old, stinky woman, and to kids, older people do stink often. We played in the yard, and then she called us to a picnic table that she had, and they brought out a platter of sandwiches. They were tuna fish sandwiches with mayonnaise. I already had a distaste for mayonnaise, and so did my sister. We looked at each other and go, "Oh no, 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 we're not eating that," you know. And we told the woman, "We're not eating it." She said, "If you don't eat it, you won't get dessert." And we said, "We don't want dessert then. We don't care. We don't want it." She wouldn't have it. She's going to win this one. She's going to win this one. She got on in front of me. I'm sitting on the bench of the picnic table. The back of the picnic table is to her back, if you can understand how she would straddle my knees, and she sat on my legs, facing me 6 inches away. And she took a tuna fish sandwich slathered with mayonnaise and forced it down my throat. She pushed it in. She held my mouth shut until I ate that sandwich. It was horrible. It was gaggy. It was choky. It was terrible. It was terrifying. And I looked over at my sister, who was sitting next to me, and there she was. She was gobbling down her tuna fish sandwich as quick as she could. So she sort of didn't want to stay the course. Anyway, I don't like mayonnaise
Understandable.
or anything white except potatoes. Okay, stores XX file in the liver. That was the function of the gallbladder.
Could I ask just a really quick question? I know. Well, how are gallbladder stones made then?
Coming up, don't worry. Hang on. The pancreas. Okay, we have 3 accessory organs: liver, gallbladder, pancreas. The 4th one we already covered. Those were the salivary glands. The pancreas. This is both an endocrine and an exocrine gland. An endocrine gland produces hormones and secretes the hormones into the blood as the blood flows through the gland. In the digestive system, the pancreas serves only as an exocrine gland, however, and delivers enzymes through ducts to specific locations. Think about it. An endocrine gland picks up hormone as it the blood picks up hormone as it passes through the endocrine gland. Once the hormone is in the blood, it's going to go to absolutely every part of the body. Now, in an exocrine gland, like the pancreas also, the exudate, the filtrate, the fluid that is produced, in this case usually an enzyme, is pushed into a duct and taken not to the entire body, but to a specific location. In this case, it's going to be to the duodenum. Okay, this paragraph I'm going to skip till I get to the next picture. Okay, here's the liver, which depresses the right side of the body. Your kidney on the left side is up higher. Your kidney on the right side is down lower because of the placement of the liver itself. The liver is producing bile salts. Now, the diagram doesn't show you where, but throughout the entire liver, and then the bile salts channel out. Here's through the left hepatic duct. Here's the right hepatic duct. Some books just call them hepatic ducts. And then we have a common hepatic duct, usually called just a hepatic duct. I'll review this in a second. Here's the gallbladder. The exit or entrance into the gallbladder is the cystic duct. When the cystic duct joins the hepatic duct, you have this longer duct here. And this is the common bile duct. Okay, now, I think the best way to approach this one is just to call this the cystic duct, which it always is called, leaving and going to, both ways, the gallbladder. And the other side is the hepatic duct. And the hepatic duct and the cystic duct join to form the common bile duct. That comes down, and at the junction of the pancreas and the duodenum, there is a small capsule called the ampulla evader. Every single book that I've looked at, looking for the ampulla evader and see the description of it, shows it differently. Everyone shows it differently. So don't be surprised if that happens to you too. Well, the biosalts are coming from the liver. They're coming down here. But they can't get out of the ampulla evader unless the sphincter muscle, the door, opens. And it won't open unless there's fat going by, lipid or fat going by. Or if there's just way too much pressure, and then it will push it, the door open slightly and dribble out a little bit of biosalt, but not enough to deflate anything. You still have a full complement of biosalt being produced and being saved in the gallbladder. The exit from the ampulla evader is through a sphincter muscle. A sphincter muscle is a round muscle. Think of your eye, and then tighten your eye like you're winking it, and then you would close off light. You could close off something. Sphincter muscles in the digestive system, like the pyloric sphincter and the cardiac sphincter, are designed to get the contents to move in one direction only and not come back. This is the sphincter of Oddi. I don't know who makes these terms up. I believe I have a picture of sphincter of Oddi for you in just a second. The pancreas is also producing an enzyme that needs to participate in digestion, and it produces pancreatic amylase. Pancreatic amylase for the breakdown of starch. More starch is broken down in the duodenum and the rest of the small intestine than in the mouth or any other place in the body. It comes this way too, and it ends up at the ampulla evader. Well, the pancreas is constantly producing pancreatic amylase, and it's got to have someplace to go. So if it's not immediately coming out through the sphincter of Oddi, the pressure generated by the pancreatic amylase and the bile salts, as they're constantly being produced, will cause a dripping effect inside, pushing the door, the sphincter of Oddi, pushing it open just slightly, but not liberating all the contents at once. When you need a fast supply, a real charge of biosalts, because you have swallowed something that's fatty, like what? Besides a tuna fish sandwich, what else is fatty?
French fries.
What'd you say?
French fries.
Oh, French fries. Yeah, even more
Avocado.
than, huh?
Avocado.
That's the one I was waiting for. Okay, avocado. Okay, and something like that would come through, and then you would begin draining this material fast. Okay, and it would refill once the fatty material is passed and the sphincter has closed again, and then it would back up any biosalt into the deflated gallbladder for further storage.
Quick question. So let's say you got your gallbladder removed, like
Yeah.
my dad, for example. Would that mean you have to eat a lot more fats so that doesn't happen? Like you don't, I don't know.
If you have your, my mother had her stomach removed, most of it, from stomach cancer, not all of it. And they told her she's going to have to eat 5 tiny meals a day. She didn't listen to them. She may have started with 5 tiny meals a day, but come Thanksgiving, she just ate a big plateful. all the time. So she was able to, but it didn't hold for her. Not sure things don't hold for everyone. Without the gallbladder, you have no excess storage of the biosalts, but you still have biosalts being produced. Okay? It just means that if there's a small amount of fat going through in your food, you're fine. If there's a large amount of fat all at one time coming by, you may not be able to emulsify it. You may not be able to digest it and absorb it all, and it will pass through you.
Oh, okay. Thank you.
Uh, Gallbladders are used to be taken out with 5-inch scars. Then the scars got smaller, and then they do laparoscopic work now. So removal of the gallbladder is the second most common operation in the United States. And immediate results.
Why is that?
Why is it? Because the gallstones that are formed, which we're getting to answer the question that was asked, can occlude or protrude into the ducts. And once that happens, it's one of the most painful things that I understand that you can imagine. And I've taken somebody to the emergency room, a couple people actually, with gallstone attacks. It's horrible to watch. Just horrible to watch. But they give them some sort of relaxant and remove the gallbladder, and except for any little tiny bit of pain from the incision, you're done. You're finished. I don't know if that answered your question as to why. It sometimes things just are. Okay. Gallstones, here's the part, are occasionally produced by the gallbladder. Well, I hope I don't have a gallstone. I don't want to go through that. I don't even care if it's laparoscopic. I just don't want it. But if you get gallstones, they are formed from 100% cholesterol. Okay. One of the functions of the liver that we didn't mention earlier is the production of cholesterol for the membrane health of the entire body. But if it overproduces, or if the production doesn't run its proper course, you can get gallstones formed, and they can lodge anywhere in the hepatic duct, but usually are in the cystic duct and the ampulovator. If they cut off that flow, the pain is intense.
I'm sorry, what did you say it was made from?
I can say that word
Cholesterol.
once a day. Cholesterol.
Cholesterol.
Cholesterol. You know what your cholesterol level is? Here you are, all
I know
pre-health
it's like,
pre-health people.
I know it's like okay, like healthy. It's not like too low or too high.
Okay, you know it's healthy, but you don't know what it is. Okay, anybody else know theirs? The reason you don't know your cholesterol level is you didn't have an incident where it was necessary to know it, probably. Some of you may have higher than you want. The limit used to be 225 milligrams per deciliter or something like that. 225 was the cutoff line. And if you had over 225, you were lipidemic. In other words, you had too much lipid. Then they changed that. No, why they changed these things, that beats me. They changed it to 200. Okay. My level is 130. And they also break it into good and bad cholesterol. And so obviously I had an incidence where it was necessary to know cholesterol. and it was like 275, and now it's down to 130.
What did you say was supposed to be under? Because I just checked and mine was 179.
179 is good. 179
Right.
is good for you. Okay. I'm assuming you're not a heart patient. You're not a heart patient.
No, I'm not.
Okay. And hopefully you won't become one. But doesn't it sort of get you when they say heart disease is the #1 killer, or well, and cancers too, or whatever. It doesn't matter how well they are able to manage these problems and diseases in the future. Something's always going to be #1. Something's always going to be #1. Anyway, yeah, a 179 is considered a very good level. Okay, now the first part of the small intestine was the duodenum. The second portion is the ileum, jejunum, and the third portion is the ileum. And they all have the same function. Functions of the small intestine are continued digestion of proteins. Said that a moment ago. Digestion of carbohydrates. Emulsification of fat. So we've got all three food groups here except fiber, which it can't do anything with. And the absorption of these nutrients that are released. A lot of times people think, oh, it digests. Well, what does it do with what it digests? It has to absorb. When any material leaves the small intestine, shown roughly here, okay, without any particular labels, it enters into the large intestine. And it enters into the cecum specifically. Here's the last part of the small intestine. It's the ileum. No, the diagram will not show you where the jejunum and the ileum separate, where one begins and one ends. But you know that you're in the ileum here because it's entering into the cecum. The cecum is the first pouch of the large intestine, which is this entire structure here. The valve that controls the passage from the small to the large intestine is the ileocecal valve. Sort of lives up to its name. Okay. And it spills the contents into the cecum. Attached to the cecum is a small finger-like organelle or organ called the appendix. It's also referred to as the vermiform appendix, meaning worm-like. When we come around to a test question, I will always use the word appendix for you, okay? But vermiform appendix is quite suitable. Have you had, anybody here have had their appendix taken out and wants to admit it?
I got mine taken out at 15.
I got mine taken out.
Worst pain I ever felt.
Before it was taken out.
Yes, before it was taken out. It was
Right.
really painful.
I had mine taken out at 8, and it must have been painful from what I can remember of it, because at 8 years old, you do not ask your parents to take you to the doctor. I asked them, and the doctor immediately said, right away, we got to take the appendix out. Oh, this was at St. Joseph's Hospital in Orange. And again, at 8 years old, I would have been, in 1955 or something like that. Well, that was a strange place. You go into that hospital room and the doctor says, I want you to breathe some of this, and he put a mask on your face. And he said, just take one sniff. And then he wouldn't let up. Scared me to death. I thought they were killing me. And then a nun, They have nuns in the operating rooms. The nun holds your hand until you're out. And then you wake up in a ward because there's no private rooms. There's no semi-private rooms. There's just big wards of maybe 30 people like you see in the old Civil War days. But yeah, that took care of it. Some people ignore it and then they run a risk.
What
I
causes
had,
the appendix to burst?
what causes it to burst is infection. You have an infection in there, and more pus and stuff and poisons are being produced. And if it's too much, it will burst. Okay, the swelling of the appendix causes the opening into the cecum to close, and now you've got a balloon blowing up inside of your body. Lower right side for most people. If you feel that pain halfway between your navel and your groin, or a little bit right of the navel, it'll be intense. You got to go to the emergency room right away. There's no thing two ways about it. We had an instructor, a guy named Scott. Scott was the vainest person I ever met. He cared about his appearance. He was always messing with his hair. He taught floral design, and I guess florists can be vain, and he certainly was about his looks. He was very good at this class, very devoted to the students. And one day he came in and he was hurting, and we said, "Go to the emergency room." He said, "I got to go to my class." I said, "No, go to the emergency room. Promise me you'll do that, you know, or I'll drive you myself." And he said, "No, I'll go right now." He lied. He didn't go. He went to his class. It lasted 3 more hours. And then the pain was so intense, he got a student to drive him. And it was too late. It burst. Now that it had burst, you have all this bacterial contamination inside of your abdominal cavity, not just localized in the appendix itself. The entire abdomen must be washed clean, must be cleaned out. So instead of a tiny little mark or scar that would have been left, he now had an almost 12-inch scar from his lower right up to his ribs on the left side. Oh, he changed a little bit after that for the better, but he made it. Okay, the pathway through the colon. This is the colon. I didn't use that term, but it's the same as the large intestine. It goes through the cecum first, then upwards through the ascending colon on your right side. Then there's a sharp turn called the hepatic flexure. And then the material inside goes across your body through the transverse colon and turns downward at the splenic flexure because the spleen is over there. Downward to the descending colon. And when it starts inward, skirting the pelvic girdle, it's called the sigmoid colon. And finally, it will pass through the rectum and the anus. The function of the colon is to reabsorb water, and that in turn compacts the waste. So we could put those two things as functions: reabsorption of water and compaction of waste. The colon, shown here, partially opened, but go across the transverse colon. You see these little chambers. Looks sort of like a ride at Disneyland, one of those people mover things. Okay. These chambers are called hostra. The singular is a hostrum. As pouches, they can move small amounts of material in the colon forward. They can move many amounts because there are many of these hostra. How do we get the hostra effect? This line here, if you follow me, is called Taeniae coli. Here it is here. You can barely see a little bit of it here, where this membrane, which we'll learn later is the mesocolon, attaches to the posterior side of the transverse colon. It attaches at Taeniae coli. There is not just one line of Taeniae coli, which most models make it look like. There are three. There are three lines. If you look at a clock, or imagine a clock on the wall, and you look at 12 o'clock, 4 o'clock, and 8 o'clock. Each of those numbers is 1/3 of the way around. In this case, the colon. Okay, we could call this one the 8 o'clock one, the one back here, the 12 o'clock one, and the 4 o'clock one is on the other side. So this is smooth muscle. Taeniae coli is smooth muscle, and it contracts differently, differentially. In other words, this Taeniae coli might contract. The next one doesn't contract for 10 minutes. The next one after that, 10 minutes after that, they keep going in sequence. And the uneven contraction causes the puckering and the formation of the hostra. If you've ever had an experience with trying to raise a Venetian blind or level oar, you know it's got two chords. And if you're trying to raise the blind all the way to the top so that you can wash the window, for instance. I know we don't like to do things like that. But in trying to raise the blind, sometimes one side goes up and the other side doesn't go up, or doesn't go up as far. It's uneven. And you can't get it to straighten out. So you got to go over there to the bottom of the blind and pull it down until it's even again, and then try very slowly, very carefully to raise both sides at the same time. And then if you do that, it's even at the top. Well, imagine if you had to raise three corners, like of a triangle. You have ropes extending from a wooden triangle on the floor. They go up and over a pulley, and if you pull on them, if they don't all come up at the same time, the material being raised will not be level. Well, here I'm telling you, the Taeniae coli do not contract at the same time. And because they don't contract at the same time, they are responsible for forming the hostra. The function of the colon, again, reabsorption of water and the resulting compaction of waste. The rectum is for the storage of waste, and the anus is a sphincter muscle again for the elimination of waste.
I have a quick question. Just out of curiosity, what does like Miralax do like anatomically? Does that make sense? Like with like the intestines and whatnot.
Are you naming a product?
I mean, just any laxative. Like you can go with Miralax if needed. Does
I
it
can't
relax the digestive muscles to like?
Some relax digestive muscles, that's true. Others are just lubricants. So and I'm not familiar enough, having never purchased that one, to be able to answer your question. Can't answer it for you. I was always told by my major professor, he said, this was at UCI, he said, there are 3 rules to teaching. Well, that's nice. Only 3. And he walked away. I guess he had someplace to go. I want to know the 3 rules of teaching. And the first rule, I did get out of him. I got him before we got out of the door, and I said, well, what's the first one? Tell me at least the first one. And he said, the first rule of teaching is if you don't know the answer, say so. Because if you come up with something off the cuff and it's wrong, they'll never believe you again. So I don't know the answer to that question. Okay. I asked him going down the hall, what's the second rule of teaching? What's the second rule of teaching? You know, and he wasn't saying know your material. That wasn't it. And he said, okay, look, the second rule of teaching is this. If there's more than just you in the room, you're probably going to offend somebody with almost everything you say. Get used to it. So that's proven true. That's proven true. And then I had to go walk with him to his next meeting to get out of him while he was walking the third rule of teaching. The third rule of teaching. What is it? What is it? Oh my God, can't you wait till later? And they said, no, I want to know what the third rule of teaching is. And he said, if the class is laughing and they're laughing at you or with you and you don't know why, and you haven't said anything funny and you haven't done anything to cause them to laugh that you know of, turn around to the board, because we had boards in those days. And before you turn around again, be sure you've checked your zipper. That was the third rule of that he gave me. And it sort of proved right very, very rarely. But I had this one student in my class, Pete Wilson. Not the mayor of San Diego, but the same name. This guy, Pete, was really ornery. He was, oh, what can I say? He's one of those, I'm sorry to say this, he was a nightmare. Okay, it's one of the ones that you dread having in the class. And we try to get along with everybody. So far, I've gotten along with all of you guys, don't worry. But Pete, oh no. And I turned to the class, I was lecturing, and Pete, looking for something here. Pete had a piece of paper in front of him. I don't know if you can see it like this. He had a piece of paper in front of him. He's sitting in the first row. That's where those people always sit. And he pounding on it. And I don't look at him. I don't like Pete. I got to admit it. I didn't like Pete. I had enough of his questions, so I didn't answer. When I turned around again, he is going crazy like a monkey, pounding on that piece of paper. So I read it. He had a note, and it said, your fly is open. That invoked rule number 3. Turn around to the board and check. And you know what? Was not. I should have thought about it anyway. Only wore Gramichis. They don't have the zipper. And I turned around and looked at Matt, at Pete, but the whole class, 30, 40 people, I don't remember how many were in there. They all had a piece of paper now. And they were pounding on it. And it said April Fool. Oh, God. Okay. Okay, that's it for the lecture material today. There's one more lecture on digestive system on Tuesday. We'll talk about a cross section of the digestive system and what it looks like. This will not be on the lecture test number 1. Okay.
Charlie, is the diverticulitis, is that an inflammation of the Hofstrom pouches? Is that what that is?
Inflammation of the what?
The
Hofstrom?
Hofstrom? Is that a diverticulitis?
Yes, diverticulitis. Diverticulitis often develops when you don't eat enough fiber, and there are pouches that form in the hostra themselves, and they can accumulate bacteria and things that can wreak havoc, with your digestive system. Okay, usually a high fiber diet can help get rid of that. Okay, it's 3:22. I want to take a break until 3:30. That's only 8 minutes. I don't, if you need longer, just take longer. When we come back, I'm going to go over the lab material. I've got some new stuff for you that should help you out. Okay? See you then. And I'm going to keep the recording going. Well, if I do and you say something, you chat, right? I'm going to stop sharing the screen now. Okay. See you at 3:30. Okay, we're back. Some of the, let me know that you can hear me or I can hear you.
Yep.
Gotcha.
Yes.
Okay,
Yep, loud and clear.
Here.
now I got them all. Oh, great. Let's see. Anthony, you still awake?
I am here, yes.
Okay. Sorry to pick on you. It's just fun.
No worries at all. It's fun.
Okay. Let's finish this off. I'm back. And am I sharing the screen with you now? Still?
Not yet.
Not yet. Okay. Will be. Now I am, right?
Yes.
Thank you. Okay. Okay. So we're finishing off week 5. And that doesn't feel to me, once we finish week 5 here, and there's only 16 weeks in the semester, that you're 1/3 of the way to knowing anatomy. We're just not. There's a lot more coming in here. Okay. Here was the lecture that we just talked about. We will add one more lecture to it on Tuesday on the digestive system. Now, do I expect that you're going to look over this? Well, you might, but do I suspect that you'd study it? No. You should be studying the material for lecture test 1, and that goes through the 8th of September. And if you want, you can bring me a lot of questions if you write them down, and hit me with those on Tuesday. On the other hand, if you're curious and you're studying, or you have a study group, as there is one of them out there, and you want to ask me a question before then, well, just email me, but do it by regular email. Okay, regular emails for regular questions. The inbox is only for submitting the chapter outlines. Okay, I got a couple regular questions in the inbox, and they just sort of lag there. You get your answer much faster with regular email. Okay. Last Tuesday, I gave you a link to human muscles, cat muscles. I believe I asked you to hone in on the first 12. On each of these, I gave you a condensed muscle list. The condensed muscle list had shorter origins and insertions, but it had the same actions. All the origins, insertions, and actions on all three of the lists are for human beings. Okay. The cat muscle list has photographs of cat muscles. Okay. And we are going to include those. I don't find them that difficult, actually. I don't think you will either. I think one thing we're not going to have is cadaver. Okay. Generally, we have a cadaver, and we use it only for the last 5 or 6 muscles. But the concern has always been with the cadaver that somebody would want to photograph it or videotape it, and then do what with it? What would you think they'd do with it?
Share it to the rest of the class.
The rest of the class has it. Oh, I see what you mean. Yeah, okay. Yes, they could share it with the rest of the class. They could share it with the rest of the world. The rule is that nobody gets to photograph or videotape the cadaver. That wasn't the reason we got it, and we promised that wouldn't happen. And I made that clear to one class, and I had to go into the back room to get something. And I came back in, and somebody told me that so-and-so had taken pictures of the cadaver, and he was going to put it on his Facebook page. Oh God. No, we're not going to do that. If I were to put up pictures of the cadaver, I would have no control over what anybody in our group does with it, and so I don't see us being able to use the cadaver for the test, unless I can take pictures of sections of the cadaver rather than the face or anything like that. Yeah, I can probably do that. But if I do, don't worry. The cadaver questions are always considered the easiest questions. Okay, we miss out on having real specimens, once living specimens. When I used to, when we did teach face to face, I always had somebody worried that they didn't want to see it. They didn't want to see a human cadaver. And I didn't make them, but they're still responsible for the questions. I did dissection class at UCI, and I only had a couple of people physically get sick, blow groceries, in other words, and run out into the hallway and sort of collapse. You wouldn't, would you? No. Okay. But we had a few people, and there was always guys. Only the guys would get a little sketchy about these things. Okay, condensed muscle list you have. I'm going to come to these last 3 that I added this morning and show you those. But first, I'm going to do the human, and I'm going to actually go through them with you. Okay, this is your homework. All this black stuff is your homework. You don't have to use the origin insertions that are here. You can use the condensed sheet that I suggested that you print out for yourself, or bookmark it and keep a tab ready so that you can look at it. Okay. The actions are the same. So the trapezius. Okay. The trapezius is a triangular muscle, stretches here to here to the back of the neck. The upper part of the trapezius, the clavotrapezius, you may still call it just trapezius, okay? Where somebody might come up behind you as a kid and grab your neck and you feel like beating them up. Okay, here, down here is the spinotrapezius, with its origin being the spine itself. And here, this part is the acromiotrapezius, referring to the acromion to which it attaches. So you have clavotrapezius up here, acromiotrapezius, spinotrapezius, but all of them may be called trapezius. Okay, the second muscle is right down here, and it's labeled number 2, the latissimus dorsi, and it originates in part on the spine as well, under the trapezius. And it goes out of sight here on the side. It's going to the humerus. It's going to the humerus to pull the arm back. Now this side of the model has not been dissected deeply as this side. This side has had the overlying tissue taken off. The third muscle is the serratus anterior. This is nice with the wording on it. It's right here. Looks like a whole bunch of fingers. Okay. These extend downward to the ribs. These are called the boxer muscles. I won't ask you that. Boxer muscles. In boxing, the jab is usually dependent upon the serratus anterior. The fourth muscle is the rhomboides. Now it shows here, but we can see it better right here. The rhomboides reach to the spine and come from the scapula. When these contract, along with their paired rhomboides on the other side, the two scapular blades are brought together.
I'm sorry, can you repeat that again?
Yeah, when the rhomboides contract, this part, okay, of the, this is the medial side of the scapula. Here's the spine of the scapula. The medial side will be drawn in, and the same would happen on the other side. So it's like putting your arms behind your back.
I have a quick question. Are the are the muscles I think the medial muscles number 4 and number 1, are they like are they joined like at the spine? Because I see it right here where like the cartilage is. I think it's what it's called. And I just want to know if they're connected, like, you know, what
Okay,
the other muscles on the other side, or are they like right at the spine?
okay. They join to the spine, but number 1, the trapeze is part of the trapezius, okay, right here. And it joins to the spine all the way up and down. Now, the rhomboides also join to the spine, but at a slightly lower level. This side over here has had the trapezius stripped away all the overlying muscles stripped away so you can see what's underneath it. This goes down lower. The model doesn't do a perfect job of showing that, but that is the case.
So for the rhomboideus,
Yes,
for knowing the origin, do you want us to know the specific vertebrae it's connected to, or is just the spine good enough?
okay. Here's where you want to have this list, condensed muscle list, okay? And for the rhomboides, the minimum you can give me, or minimum you can expect me to ask you, is that the origin is cervical vertebra 7, that's the vertebral prominence, to T5. And the scapula is the origin, insertion, I'm sorry. Okay, so this is the minimum here. You can give me more. You can give me what I have on those full sheets, but this is all that's necessary. Now, when I say you can give me more in speech, yeah, but you'll be taking my test. And my test has got to be geared for everyone. And since I've provided you all with this condensed version that has the full actions, then I'll be asking based upon the condensed origins and insertions. So for instance, if I were to say, what is the origin of the rhomboides? And I would have multiple choice. And one of the answers would be C7 to T5. Okay. Another might be ribs, 3, 4, 5. Another might be scapula. You have to hone in on that one. Now, I'm not going to actually do it quite that way. I'm not going to say, what is the origin of the rhomboides? Because if I did, somebody unfortunately might have my sheet, this sheet, copied. All they have to do is look up rhomboides. There's the answer. So instead, the test is going to be set up that the question says, what is the origin of this muscle? I won't tell you the name of the muscle. I'll show you the muscle. You have to first know it in your mind. That's easy enough, actually. You're going to be doing that anyway. And then you convert it over to the origin. That will take up enough time that anybody who's, if there were anybody, trying to look up the answers will run out of time. Does that make sense to you guys?
Yep.
I can say it again, or it made sense.
It makes
So,
sense.
Makes
okay.
sense.
The pectoralis minor. Okay, but you probably don't know what it looks like yet, but you will. Pectoralis minor. I would say, name this muscle, and then I would give you 4 choices or 5 choices. One being pectoralis minor. That's if I only wanted to know the name of the muscle. If I wanted to know the origin for the pectoralis minor, I will show you the pectoralis minor and just say, what is the origin of this muscle, without telling you it's pectoralis minor. Okay. Don't worry, you're not doing extra work to do that. If you know the muscles, you're in good shape. And 51% of the test is just naming what you see. Okay,
Of this lecture exam, right? Coming up.
no, this is practicum.
Okay. Oh, okay. For the next. Okay.
This is for practicum 2. Right now, you have all of the information you need for lecture exam 1 through September the 8th. Okay, and now I'll go back to here. Okay, we did rhomboides, pectoralis major. Okay, this person's facing you, and it's your upper chest. Here's the pectoralis major. Look at the insertion. It's huge. It's all the way around here. It attaches to the sternum and in part to the clavicle. And what's the pectoralis major going to pull on? If you work your own pectoralis major, you can put your hands at your side and you would sort of shrug inward. Or if you put your hands straight out, right and left, and grab two pulleys and pull them towards you and across your chest, you'd need the pectoralis major's force to do that. And the insertion is going to be the humerus again. Actually try to make these muscles move. The pectoralis minor shows here, so we don't need to go backwards. And it's flayed in several parts. It's underneath the pectoralis major. So I would have to strip number 5 back in order to see number 6, the pectoralis minor. The deltoids are simply the shoulder. There are 3 deltoids, just like there are 3 trapezius muscles, but you only need to give me trapezius for that, or for this, the word deltoid. The homework is learning the origins, insertions, and actions. The supraspinatus is here, number 8. It's above the spine of the scapula. Here's the scapular spine. And the infraspinatus is most of the area below. It's not all of it. There are a couple of other muscles down here that we'll get to later. But here's the infraspinatus and the supraspinatus. Now this one takes a little bit of getting used to. You may have to get a book. You may easily Google it. Number 12. What's number 12? I'm being asked what number 10 is, but I don't know what number 10 is. I do too, but if you didn't know what number 10 is, there's a number 12 there as well, and a number 11. So here's 11. Let's start with that. 11 is the biceps brachii. Okay, you all know where your biceps are. That's the muscle we love to flex and show off if we've got it. So here's the biceps. Biceps means it has 2 heads. That means it's not one insertion, one origin. Okay, one end or the other has 2 things. This one splits. Okay, it starts down here, 1, and it splits right here, and it goes to 2 places that's not shown. It's the biceps brachii. The muscle underneath the biceps brachii is the brachialis. The brachialis extends all the way over to here, all the way over the other side. It runs completely underneath. The brachialis probably is more forceful than the biceps brachii, but they always work together. So to raise your forearm or to flex your forearm, you're going to definitely use the biceps brachii, but with it, you'll use the brachialis. A term that I'm going to give you in print is synergist. These 2 muscles are synergistic because they both work to do the same function. They help you out. If you're trying to, for instance, push a refrigerator onto a lift on the back of a truck, and you can't quite do it yourself, somebody else comes along, then the two of you are synergists getting the job done. So biceps, brachialis here, and now what's that number 10? The triceps, and here's the triceps. Here's the brachialis. Where's the biceps? It's this one up here. The triceps is this muscle here, and it is also this muscle here. It would have been nice, whoever taped this, it was in my class, to have put number 10 on here too. The triceps has 3 heads. 1, 2, and the third one, like a lot of times you'll find this, located in between the first 2. You have to spread it with the probe to see it. I will never ask you the hidden ones, never. Okay. And I wouldn't even put this one up until I got a one that was better that showed 10 and 10. Triceps and triceps. Okay, that's what I asked you to look at so far to get down to number 12. For the cat muscles, we're going to do the same ones. Okay. The trapezius was the most superficial of the back muscles. The trapezius ran from this point back here over to here and to the neck. So it was 1A, 1B, and 1C. I won't ask you the parts. Again, the name for the answer is trapezius, but they were the spinotrapezius, acromiotrapezius, and at the neck, the clavotrapezius. The latissimus dorsi was below. It's attached to the lumbodorsal fascia, a term I haven't given you yet. Don't worry about it until I do. But here's the attachment, the origin of the latissimus dorsi, coming forward until it reaches the humerus, a large muscle on the back side of the human and the cat. Now, so we don't have to come back to it. Number 4 up here is the rhomboides. So here the 2 shoulder blades have been stretched apart, and you can see the rhomboides muscles looking somewhat like a radiator vent or a heating vent. Their normal position is to pull and contract, and that would pull the 2 scapular blades here and here in towards each other. These are the rhomboides. So what we're missing here, 2 to 4, is number 3. And that's going to be the serratus anterior. Here's the latissimus dorsi, lifted up, that same one. And underneath it, here's the lower part of the scapula. And extending from the scapula are these rays of muscle. 1, 2, 3, 4, down in here 5 and 6, coming out like a starburst. These are the serratus anterior. The pectoralis major and minor. The pectoralis major and minor's orientation is different in the cat than in the human. Okay, So here's one where we get the question, well, why do we bother doing it then at all? Uh, we do it for the dissection experience, which is usually required by nursing schools that you go to. They're all going to make exceptions in California anyway, and I'm sure everywhere else, for during the pandemic, that having to take classes online. But those classes that will really benefit are those that do virtual dissection then. And so we are going to do the cat. You'll appreciate it more later. Number 5 is the pectoralis major. It's in a shield shape. Follow my little cursor going up to the sternum, and it goes back to the other side, and then comes across. Underneath it, below it, and only partly covered by it down here, this muscle is the pectoralis minor. Pectoralis minor in the cat. So we don't have to come back to it if that's okay with you. Doing it out of order, number 11. The only other muscle on this side of the cat for the upper body. This muscle here is the biceps brachii. That's the biceps on the cat. The deltoids. The deltoids are the numbers 7. This is one of the deltoids. This is the spinodeltoid. This is the acromiodeltoid at this rounded part of the shoulder. And way down here is the clavo or cleidodeltoid. The clavotrapezius is up here, not labeled, and it runs into the clavodeltoid. Sometimes muscles can attach to other muscles. Okay, so if this one is named this one or this, it's deltoid. And you may give me the origin insertion off the condensed sheet. No matter where I pin it or point it out on a test, you may give me the condensed origin and insertion for your answer. Now, number 12, since we don't need to come back, is this muscle here. This is not the biceps brachii. The biceps is on the other side of the arm in the cat. And this one that comes out here is the brachialis. It works with the biceps all the time as a synergist. This is triceps brachii. This is another head of the triceps brachii. There's the two heads. The third is in here. If I find these, I see triceps, triceps, I'm finished now. The next muscle out is the brachialis, always. The supraspinatus is number 8. Okay, here's the shoulder blade lying back down. We don't have it stretched to see the rhomboides. We do have the acromiotrapezius peeled back and cut. Here's the spinal trapezius. Here's the acromiotrapezius, but I pulled it back, cut it so that you can see the back of the shoulder blade. And the upper part above the spine is the supraspinatus. Where's the spine? The spine is right in here. everything's still attached to it. And the area below that spine here, number 9, is the infraspinatus. 10 is another triceps brachii. Okay, so that takes care of the first 12 there as well. And that's a good start. Let me show you the new material I've added. This is the version of the back muscles, abdominal muscles, and then the third one, chest muscles of the cat. This was not done by me. That probably means it's it's not worse, it's not better. The best thing about it, it gives you 2 looks, different looks, and I think that really helps. Some of these are really nice. Some of them don't have markers, which I'll add this weekend to them. But okay, muscles of the back. Takes the muscles we're looking at here are listed. There's one to be added. That's why I asked you to get a pencil. Don't do that to me. Just stop. Oh. It's better to break it out anyway. Okay, you can see that this was done on PowerPoint. Okay, when I run it on my computer, because I can save it, and you can save it too, it will actually have motion. Not much, but enough. Here's our trapezius. Okay, spinal trapezius, acromial clavicle trapezius. You only need to know the term trapezius. Now below it, as if you might want to use it to make flashcards, it has the origin, insertion, and action. The actions of all of the muscles are the same as on my sheets, no difference, but the insertions and origins on this page are longer. If you learn them this way, you'll do fine. If you learn them the way I've given you, you will do fine. This instructor is requiring the longer version, but not requiring the cat. So it's a trade-off. And I'm sure that you could do well under either circumstance. So if this is downloadable as PowerPoint, then you have PowerPoint, you can fix these if you wish to fix them and change the origin and the insertion before you make cards. The latissimus dorsi is located down here. Doesn't enlarge, so it's a little bit on the small side. And here are the origins, insertions. Now, when it asks you a question that you don't know the answer to yet, like, can you name a synergist, one that works with this? The answer that I'm going to teach you is teres major. If you don't know it yet, just put it in parentheses. Don't put it anywhere at all if you don't want to. I will be giving you everything you need for our test. But right now I'm giving you a look at some material produced by another instructor. The supraspinatus is deep to the trapezius. Well, now which is the supraspinatus? It's not labeled. It's number 1. Here, if you might have the need to get your book out and look at it, or you can look at the photos that you and I just went through. Trapezius is number 2. They really want to show only the supraspinatus. So as I said, I just got these yesterday, and I downloaded them to my computer, but haven't opened them just as a straight PowerPoint. And when I do, I'm probably going to be able to remove the excess numbers for you. Still won't give you any problem. The infraspinatus, nice picture. Okay. And on the other side, the infraspinatus. Functions. Don't worry about these. Can you name a synergist yet? The subscapularis.
Was it number 7 on that picture?
Yes, it's number 7. Yeah, what I'll do tonight is, like I said, I'll try to remove the excess numbers that aren't associated with the picture. Obviously, what happened here, have you made PowerPoints yourself? If you haven't, I'll tell you something. You do not want to keep having to make these damn arrows all the time, over and over and over again. So what this person has done is included the arrows, but unfortunately, no legend, not a real legend. But I can fix that for us. Okay, the subscapularis shows here, here, and here. More information here. Here's the rhomboides. They've been broken up into major and minor, but you're only going to be asked what's on my chart. So rhomboides or rhomboids is what you're looking at. And this shot of the cadaver, here are the rhomboids here. And here is the trapezius. The teres major, you and I haven't come across yet. We will. Okay. So if you can, just either skip this or forge ahead and teach yourself a little bit. Teres major is here underneath the infraspinatus. Here's the infraspinatus. This one here is the teres minor. And that we haven't had yet. I'm not asking you to be clairvoyant, or whatever the word is, mind reader. I'm not asking you to tackle anything we haven't done yet. We have only done muscles 1 through 12. So teres major and minor. It's nice to see them labeled, but you'll be using them later. You'll be using them later. This one is the one I want you to write down, please, is the erector spinae. Erector spinae. Runs right down your back, both sides. Probably the cause of most back pain. It flexes your back against your trunk. In other words, if you are standing upright, lean over backwards a little bit, if you can without falling, that's the erector spinae. If you're lying flat on the ground, okay, and you want to raise and you're prone, head down, and you raise your head and your chest up a little bit, it's the erector spinae that's doing that. If you're doing many different types of strokes in swimming, the erector spinae is very important. Here it is. I'm not going to ask you the various parts of the erector spinae, just erector spinae. So this bit about I love spaghetti, how to remember the different parts, I'll remove that or remind us that you only need erector spinae. Now, erector spinae is not on your full sheet. I haven't given it to you where you can punch on it, and I haven't given it to you with origin, insertion, or action. So you will only be asked to identify this. Only asked to identify. The second part was muscles of the abdomen. There's only a very few here. External oblique. Okay. We haven't done that one yet. It's not in 1 through 12. So you can look at this or you can hang on to it. It's labeled as a handout, and definitely it'll be useful to you later. The external oblique is here. My figure, if you punch it, is frankly better than this. Okay. The oblique muscles compress the abdominal contents and allow you to twist your waist. We'll come back to that later. Okay. Internal oblique, we haven't done yet. We haven't done any of these yet. Okay. So I'm going to just, in fact, back out and tell you that so far the muscles of the back that were in the first set, those are the important ones, and muscles of the chest. See what we got here. Pectoralis major, minor, serratus anterior, and then the intercostals. Okay. The pectoralis major is here. Well, we saw it much bigger. The pectoralis major is here. Here's origins, insertion, actions. Here's the pectoralis minor. So we've seen that before. Pectoralis minor is over here. What's missing on these is that they don't have any arrows to tell you which ones they want you to see. So I'll be looking to add those for you tonight. Okay. The serratus anterior, this one's got a nice arrow. It's just not very large. And even if I bust it out, it's not going to enlarge much. Here's the serratus anterior. The external and internal intercostals, the more you hear about them, the better. These are our last two today. Here are the ribs, sternum, and in between the ribs we have muscles. We have some muscles that are close to the sternum, and we have muscles farther away. And that's what's being pointed to here. These three, and this one down here, and this one way back here, these are the external intercostals, and they elevate the ribs for breathing or for inhalation. Or in this case, they want to use the word inspiration, that's fine. The external intercostals. The star here is on external intercostal. Over here, these are the external intercostals, unlabeled. The external intercostals raise the ribs, increase the thoracic cavity volume. That decreases the pressure or would, except immediately air is drawn in. So very important, the external intercostals. The internal intercostals are the inner muscles. Here, 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 not out here. Let me go back to the first. Okay, this one showed the external intercostals. The internal were here. The internal intercostals look bigger. They're probably not. About the same size. The internal intercostals cause the chest cavity to collapse, cause the sternum to come back, lower the ribs. When you breathe in, that takes effort. But when you breathe out, just sitting where you are right now, you breathe in, that takes a little effort. You don't notice it, but now you realize, of course, it does. But if you stop breathing and let yourself relax, the air just comes out by gravity because the rib cage lowers itself by its own weight. So we don't even need these muscles, the internal intercostals, to push the air back out. Okay, or we wouldn't unless we're running or moving fast or exercising. Because in order to exercise, you have to breathe faster, you have to breathe in faster. And the only way you can breathe in faster is if you get the internal intercostals to reset everything, to quickly pull the rib cage back down again and force the air out. So the action of the internal intercostals is it depresses the ribs for force expiration. Without that action, you're just going to walk slowly for all your life. Now, here's what I'm going to do. Okay, a little bit later you can ask me for them, but the main one that we covered that was additional is the muscles of the back. The muscles of the abdomen were not completely labeled, and the muscles of the chest had some things in there too that we're not ready for. So I'm going to temporarily it's not letting me do that. Oh yeah. Okay. I removed those bottom two. So if you want to go ahead beyond questions or muscles numbers 1 through 12, you can, but I would not go past this handout, muscles of the back. Okay. The other two, they'll pop back up. They'll be published again as soon as I get a chance to make them a little bit more appropriate for us. Okay. Any questions about next week? The test? Anything?
So anything, everything before September 8th is on the test, right?
No. Everything before and including September 8th.
Okay, got it.
Big difference.